All right, so this is a follow-up to the domain and range life hacks that I recorded. These are some examples I want to run through with you today. I'm going to stick with red and blue as our go-to colors. So domain is going to be blue, range is going to be red, just like our previous video. And so let's go ahead and start with our linear equations, okay? So these are the two equations that we have, all right? And these are the two graphs, okay? So remember, domain is left to right. So I'm going to find the point farthest left and see that it's -1. It's a closed circle, so my little, with a line through it, x, all the way to this one, which is a +1, but it's an open circle, so I'm going to leave it just like an open alligator mouth sort of a thing. Okay? Range, we start at the bottom, and so that's at -6. It's a closed circle, y, all the way up to this, which is 8, and an open bracket, or open alligator mouth. So see, not too shabby, right? Okay, so let's look at this second one. So this one, it looks a little different. Excuse the crazy little thing going on there. Made a mistake. Domain, x values. So farthest left, I've got an arrow. Okay, that arrow means I'm going to keep going to the left. Okay, no matter what. Now, if this graph wasn't here and I was just going to the left, these numbers would get smaller and smaller and smaller. These negative numbers would get smaller and smaller and smaller. So instead of getting bigger and going to a positive infinity, they're actually going to negative infinity. So negative, oops, I was about to draw an 8, so we'll do that. Negative infinity. Remember, infinities get the open, okay, to this one, which is a 1, but it's a closed circle, so I'm going to put that line right underneath it. Okay? So range is from lowest to highest. Okay? So range, our lowest, is at -7 with a line underneath it, y, the arrow. Okay, that arrow still means in terms of y that we're going up, which means to positive infinity. Okay, so those are some examples with linear equations. Into the year, we're going to actually end up talking about these types of equations called quadratics, or quads for short. And these are what these equations look like. So if you plug them into your calculator, into graph, and graph them, they look like this. I think they're fun. They look like little Nike swoosh signs or like gigantic sad face signs. These are some of the most real-world application type equations that we'll see. But right now we're just looking at domain and range. Okay, so domain on this first graph, this x squared plus 2, -1, and it's an open circle, so x all the way to 2, and that's a closed circle, so I want to make sure that line is there. All right, so there's our domain. And guys, if you do this right, your graph should end up in a little itty-bitty box, okay? So these are the types of graphs that confuse people, because when we go to do the range, most people want to start here at the open circle. But remember, range isn't from left to right, it's from bottom to top. Okay, so our lowest point on our graph is right there at 2. Okay, and because it's part of the graph, it actually is going to be closed. Y, all the way up to the highest point of the graph, which is also closed in an 8. Okay, so looking at this last example of a quadratic function, domain, well, farthest left gives me an arrow, and it's pointing down, so it's going left, which is negative infinity, x. And then on the right-hand side, those are the positive x values, which means we're going all the way to the right, and those arrows means we never ever stop. So the domain is actually from negative infinity to positive infinity. All right, and we actually call this all real numbers. Okay, or we could leave it negative infinity to positive infinity. That works too. Okay, now the range is lowest to highest. And if we're looking at the y-axis, both of these arrows are pointing down. And these numbers right here keep getting smaller and smaller and smaller and smaller and smaller, which means we are going to negative infinity. Y. And then our highest y value is at 4. Okay, so there's our domain, there's our range. And the last two examples I have for you are what we call exponential functions. So these are fun. I like these probably the most, which is weird for some people. The cool thing about an exponential function is unless they have circles at the ends of them, your domain will always be all real numbers. So negative infinity to positive infinity. Unless there's those little circles that tell us we have to start and stop somewhere, all real numbers every single time. So I just went ahead and put it for both of them. Okay. Now, something special about our exponential functions is that they have this invisible line here, and it's on the x-axis. Okay, that invisible line is called an asymptote. Okay, it's a line that your graph can get really, 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 really close to, but it will never touch and it will never cross. Okay, so both of these graphs have asymptotes. So this one right here looks like it's getting really, really close to it. In fact, it looks like it's touching it, but if we zoomed in, there'd be a space there. So it's actually not touching the x-axis. Okay, so what is our range? Okay, our numbers, our y values are getting so tiny, but they will never actually reach 0. So that means our y values are going to be greater than 0. They will never equal 0 because we have that asymptote there, but they will be greater than 0. Okay, because notice our graph goes up. Okay, so for this one, we still have that asymptote. There's still that 0 there. Will it ever be 0? No. But notice our graph goes down. So instead of y being greater than 0, now y has to be less than 0. Okay, let me know if you have any questions.